Welcome back, everyone. Got a chemistry exam coming up? Well, you are in the exact right place. Today, we're diving into the ultimate chemistry exam review, focusing entirely on the critical differences between metals and nonmetals. I know how tricky these physical properties can be to keep straight in your head, especially when teachers start throwing in those sneaky exceptions. So, grab your notebooks, get comfortable, and let's get focused. We are going to break this down so clearly that you'll be acing these questions in your sleep. Here's the game plan for today's explainer. The periodic table divide, physical properties of metals, physical properties of nonmetals, a quick exam revision table, and we'll wrap up with some final practice questions. All right, Section 1, the periodic table divide. Think of the periodic table like a map. There's an actual dividing line right down the middle, separating our two main territories. Everything on the left, that's metal country. We're talking everyday elements like sodium, calcium, and zinc. But if you jump across that line to the far right side, you're in nonmetal territory, home to carbon, fluorine, neon, and so on. Basically, an element zip code on this table tells you exactly who they are. Moving right along, Section 2, physical properties of metals. Okay, I want you to star, highlight, and heavily underline this next point. All metals are solid at room temperature, except for mercury. This is an absolute classic exam trap. When we think of metals, we usually picture a heavy solid iron bar, right? But mercury, the stuff used in old-school thermometers, is actually a liquid at room temperature. Seriously, do not let that trick question catch you off guard. Now, let's nail down some of that crucial scientific jargon. First up, luster. By definition, luster is just the property of a metal being visually shiny. If an examiner asks you why a metal catches the light so well, luster is the exact vocab word they're hunting for. A really perfect everyday example here is gold. Picture a bright gold chain or a shiny gold coin. That super reflective shine, that's luster in action. Honestly, connecting these fancy terms to stuff you see every day is the absolute best way to make them stick in your brain. Next up, we have ductility. This is the physical property where metals can be drawn, stretched, or essentially pulled into long wires. It's super important not to confuse this with our next term, so lock this in your head right now. Ductility equals wires. Let's look at how this actually applies in the real world. Copper is the ultimate example here. Because copper is incredibly ductile, we can draw it into long wires to conduct electricity, literally powering our everyday lives. And speaking of conducting, metals aren't just great at conducting electricity. They're amazing at conducting heat, too. That's exactly why we use metallic pots for cooking. They take the heat straight from the stove and move it right into your food. All right, now let's contrast ductility with malleability. Malleability is a metal's ability to easily be shaped or bent without breaking. So if ductility is all about being pulled into a wire, malleability is about being smashed, flattened, or molded. Picture this. You take a massive, heavy hammer and repeatedly strike a chunk of iron, flattening it out into long, thin sheets. Because iron is malleable, it doesn't just shatter into a million pieces when you hit it. It actually changes shape. Use that visual of a hammer striking an anvil as your mental hook for malleability. Which brings us to Section 3, physical properties of nonmetals. Let's flip the script and look at the right side of the table. Unlike those solid metals, nonmetals are most often gases at room temperature. But, and teachers absolutely love testing this, there are exceptions. Carbon and iodine, they're nonmetals, but they're solid at room temp. And the biggest exception of the whole bunch? Bromine. Bromine is a nonmetal that is uniquely a liquid at room temperature. Seriously, write that down. Bromine equals liquid. Now let's contrast their appearance. While metals have that gorgeous luster, nonmetals are, well, dull. They just don't reflect light very well at all. Think about a lump of charcoal. If you hold a piece of dark charcoal next to a shiny gold ring, the difference is literally night and day. Charcoal is flat, dark, and perfectly sums up the dull nature of nonmetals. All right, sound the alarm because here comes another massive exam trap. Generally speaking, nonmetals are terrible conductors of heat and electricity. They act as insulators, like plastic, right? It doesn't conduct a thing. But there is one huge exception. Carbon, specifically in the form of graphite, can actually conduct electricity. And where do you find graphite? Right there inside your pencil. Yep, pencil lead is a nonmetal that conducts electricity. Don't let them trick you with that one. Let's talk about the exact opposite of malleability, brittleness. Brittleness is simply the property of not being easy to bend without breaking. When you apply serious force to a non-metal, it's not going to flatten out nicely like iron does. Think of glass as your everyday example here. Glass is incredibly brittle. If you try to bend a pane of glass, it doesn't gracefully change shape. It just snaps and shatters into pieces. That sudden breaking under pressure, that is the defining feature of brittleness. Finally, let's talk about density, which is a super common comparison on the syllabus. Comparatively, metals have very high density. They feel hard, packed, and heavy in your hand. Nonmetals, on the other hand, are the complete opposite. They're far less dense, much lighter, and usually don't feel heavy at all. All right, Section 4, Quick Exam Revision Table. Okay, here is your ultimate cheat sheet, so get ready to take some notes or a screenshot. Notice how perfectly these two sides contrast. For state, metals are mostly solid, nonmetals are mostly gases. Appearance, metals have luster, nonmetals are dull. Conductivity, metals are good, nonmetals are insulating. Shape, metals are malleable and ductile, nonmetals are brittle. And finally, density. Metals are high, nonmetals are low. If you can quickly sketch out this table on your scratch paper right as your exam starts, you are going to be absolutely golden. And finally, Section 5, Final Practice Questions. Let's do a rapid-fire pop quiz to see what stuck. Question 1. Name the only metal that is liquid at room temperature and the non-metal that is liquid at room temperature. We spent a lot of time on these exceptions today. Think back. The liquid metal? That's mercury, like in those old thermometers. And the liquid non-metal? That would be bromine. Fantastic job if you remembered both of those. All right, let's try question 2. Which nonmetal form of carbon is a surprising conductor of electricity? Remember our rule, nonmetals are usually insulators. But this specific item, you might literally be holding it in your hand to take notes right now. The answer is graphite. Carbon, in the form of graphites, conducts electricity beautifully. And for our final thought question today, if you were hired to design a brand new heating pot for a kitchen stove, why wouldn't you use a brittle, insulating non-metal? Think about the real-world application here. A heating pot has to transfer heat to actually cook the food, right? So an insulator would be completely useless at that. Plus, it has to survive being banged around in a kitchen. If it's brittle, it would shatter the second you dropped it. And that, my friends, is exactly why we rely on the high density, high conductivity, and malleability of metals to cook our food. Understanding why these properties matter in real life is the absolute key to mastering chemistry. Keep reviewing that table, keep spotting those everyday examples, and you are going to absolutely crush this exam. Thanks for joining me for this explainer, and I'll see you next time.